Hello everyone and welcome back. So what we are going to do now, we are now starting a full end-to-end solution where we're going to build the recommendation system using k-nearest neighbor algorithm within the SQL environment. And I believe that will be very beneficial for those folks who are not keen to install Python libraries or any other libraries on their production database server because they're always concerned about the security and patches. And once we install the Python packages, it's always a cumbersome process, right? So what I'm going to show you is how you can create or develop the k-nearest neighbor algorithm within the SQL environment, and you can use it to recommend recommend the suggestion to your user. In upcoming videos, we're gonna see how we can enhance it. Obviously, like any solution, I always say that start with the simple one and then slowly add the complexity. That's the most easy way to build any kind of solution. And you can see in the industry as well that whenever we start something new or in our organizations or job, we always start with small, and then we slowly enhance it with more and more complexity. Depends upon the scenario that comes on our way, right? So in this video, I'm going to discuss the data model that we are going to use for our recommendation system, and obviously because that's the key piece, which is sourcing the data to the algorithm, and then algorithm will generate the recommendation, and then we'll see whether these recommendation make any sense, and if the algorithm is recommending, why it is recommending these suggestion, right? So let's go and let me show you the data model. So let me spin up my dev. Now you can see my dev environment. So you can see the tables are pretty small and straightforward because I want to start with simple. So it can help you to understand the two different side of data and analytics. On one side, you're gonna see the data engineering, and on the other side, you're gonna see the machine learning or the data science and analytics part of the analytics domain, right? So you can see I have got three tables. One is obviously the user one, and by the way, we have multiple techniques, so we and that we can use to do the recommendation to our user, and some of them are really advanced, like which are based on the matrices multiplication, and obviously we have content filtering based algorithm. We're gonna see them in the future once we build a bit advanced system, but I think the in this video I'm going to show you the power of the machine learning algorithm, that how you can build some algorithms even with the minimum knowledge of machine learning, that can really help your organization to do some amazing work, right? And that's where we're gonna see the k-nearest neighbor, because that's the simplest one to implement. Although we can implement the logistic regression, but that is more like for classification. And in the future video, we're gonna also use k-nearest neighbor algorithm to classify things as well, right? So you're gonna see the two side of the coin, where you can use the k-nearest neighbor algorithm, not only recommending but also classifying the object, right? So let's dig into these table. Let's see what we have in these tables, right? So let me first go and show you the user table, and you can see I've put them in the nice schema, which is called feature mart. By the way, in the real life, we have multiple attribute, but if in some cases you have some minimum attribute with the table that you have to use, right? So what I'm going to do, at the moment, I'm totally relying on the rating that user is providing against any book. By the way, in this scenario, we have a book business that provide the books to its customer, and obviously after reading the book or after selecting the book, user provides some rating to the book, and based on that, now this business is thinking that okay, we should develop some intelligence into the system, so system can recommend user some other books, so they might like based upon obviously their feedback, and if their feedback is matching some other user and they already provide some good feedback to other books, so those book might be in interest of this user. And obviously over there we have multiple way to recommend. We'll see it in the later video, right? So the first table, we have the user where we are keeping their location and we are keeping their age. Now the second table which we are going to see is the book information. Obviously that's the main business that we have. We have all the book information, and you can see we have the book title, we have the book author, year of publication, publisher, and obviously these last three are more like the image thumbnail of that book if you want to put that book on the website. All right. And now the third table is going to be the rating. So whenever user provide any rating to the book he read, we will put that rating into this table. And you can see this table is quite big because we have a lot of rating against our book. And just to show you the volume, let me just run. So you can see we have 1.1 million ratings about the books, right? And obviously we are keeping the user ID and the ISBN, which is the unique identifier for each book, and the rating that user is providing. Now that's the small model that we are going to use, and obviously in the real scenario you have many more tables that you will refine it to prepare the input that you can feed into your machine learning algorithm, right? I'm starting with the most simple scenario so you can easily understand, and then obviously once we have all these three tables, now we need to join them in a sense that we can get the flat input, right? Because with the machine learning algorithm, you need to feed the input in a flat table format. We have already seen it in the logistic regression. We have already seen in the linear regression implementation. We have seen similar thing in the random forest algorithm implementation in PySpark. So we're going to follow the same pattern. For somehow we're going to actually link these three tables, and then we'll see if we can flat this output into one table instead of keeping three tables separate. So obviously if you know the database, we have the database background, what we're going to do, we're going to actually create a view based on these three tables. And let me just show you, I've already created it. So I'm just going to show you the implementation of that table. So you can see we have the view. I'm just going to alter it, which is coming to us, and view is more like a wrapper upon the SQL statement, right? So while you write the SQL statement that produce the outcome, if you want to create that script as an object, you can create the view. The difference is the view doesn't hold any data. The data is still sitting within their base table, right? So view is more like the logical representation of this table, which is containing your data, right? All the whole advantage of using view that it will encapsulate the complex logic underneath and just provide you the flat output. Like you can see in here, if you remember in our previous video, I've already told you that we have some issue with the data duplication. So you can see I'm just getting the unique record from my user table. So that's why I'm using this string, and then I'm obviously connecting it with my book rating table. So if you can see in here, So our first table is obviously the book rating, and then I'm representing it with alias, which is BR. And then I'm because that book rating table is more like, the glue between the other two tables. So you can see we have the common ID. On one side, that book rating table is connecting to the user table. On the other side, it is connecting to the book table. So we're going to apply the same logic into my view. On one side, we are linking my book rating table to my user, but I'm actually using a subquery, because before I join it with the book rating, I just need to filter the duplication, right? So that's why I'm using the distinct clause. Similar way, I'm also removing the duplicates from my book table, because if I don't do it, that's going to impact on the book rating count, right? So there's no point for me to keep the duplication. That's not going to impact on or that's not going to improve, or change the outcome generating by the algorithm. Or in the worst case, it's going to actually slow down the performance of the algorithm. So that's why I'm just getting the unique records. So these are the three tables. I have linked them with their common fields on either side. And now what I'm going to do, I'm going to actually normalize the rating, because the rating scale we have in this case is between 0 to 10, and 0 is the lowest rating and 10 is the highest rating, right? So what I'm going to do, I'm going to divide the rating, and that's where we normalize the output as part of the feature engineering. I want to bring that rating between 0 to 1. So what I'm going to do, I'm going to divide it from the max minus min of the rating, which is obviously 10 minus 0. So in our case, it's pretty simple that I'm dividing it by 10. So it will bring the rating within 0 to 1 range, and that will really help the calculation, and it will regularize the feature that we are going to feed into the machine learning model for us, because we are only using the book rating column at this stage. So that should be all right. That's not going to create any issue for our algorithm, right? So but it's still better to normalize it, because later on, once we have more and more feature, that practice will really help us. Now, so I think we have discussed, and obviously, if you remember, we have already discussed the window analytical function, and I'm going to actually allocate a unique row number to each row, right? Because obviously we don't have any unique key, so I'm just going to create a virtual unique key based on the row number. And you have already seen the analytical function. If you don't understand, please watch my video on the Windows analytical or ranking function. All right, let me quickly show you the outcome. So you can see we are getting 173, because I'm just using the inner join to join the records on both sides. So all those ISBN which are sitting there, but they are not coming from any user or not coming from any book. They are just sitting there. They're gonna be filtered out, right? So I think this is all good, because we have a very nice data set that we can use, 173,000 records. It's a handsome data set that we can use to see the evaluation, the performance of our algorithm as well. So that's the outcome. So now you can see we have flattened the outcome. The rating is now between 0 to 1. So our algorithm is our data set is now ready to feed into the machine learning algorithm. So in the next video, we're going to discuss the k nearest neighbor to see how we're going to actually feed the data into our k nearest neighbor algorithm. Stay tuned, and I'm going to see you in the next one.